Hello, I think I am audible, right? So this is our second live stream on Codeforces contest, right? So let me explain you these problems one by one, and I'll also I'll also explain you these things one by one, right? Let me tell you. Let us start with what we are asked in the first problem. The first problem is basically easy. I think and let me tell you, I have only solved the first two problems, right? Till now, I joined it late, so let us start with the first problem. We are going with Iskander and the drawings. So they give exactly like this in most of the online assessments and also in courses. So this is the type of way they ask you the DSL problems. So it is nothing but you will be given a string. It will be something like this: asterisk asterisk hash 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 and then asterisk asterisk and then hash 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 then hash. So the whole problem goes like this. Imagine there is asterisk for two times or asterisk for one time. One thing what we are asked is there is one person Iskander, whatever the sequence is Iskander, and then there's another person. Let me tell you, Viru, I think, Yura. So they'll pick a subarray or substring of these hashes, right? So there are two things. They start with at the Iskander starts at the from the left, and Yura starts from the right. Let me tell you how they do it. And they cancel each of the line. Let me tell you. So take these hashes for some time, right? So Iskander, Yura. He cancels once. Now they both have only one, right? They both will be cancelled only in 1 second. So to cancel they both cancel at the same second. So how many seconds do they need to cancel all of these hashes, right? So here and here once, here and here once, so two and then three. So for this only one time they both take only 1 second, so four. So totally four. Let me tell you, imagine I have only one hash. They both, only one hash or only one line. So the Iskander and Yura, both of them goes with only 1 second. That's the max I can get. Now I have two hashes. They both are starting at uh, here and here. So they both take only 1 second. Now I have three, right? So first Iskander cancels this and then cancels this. So and then there is only one left. So there will be only 2 seconds, right? So if I tell you in this way, hash and for many times three and many times, I'll tell you how we can solve this easily. For this, they for only one. I'm just writing like this. For one, they take only 1 second. For two, even for two, they are only taking 1 second. For three, they are taking 2 seconds. For four, How many seconds they take? One here, and then another one here. So 2. For 5 as the size. 1, 2, and then 3. So 3 here, and then 3 here, and then 4, and then 4, 5, and then 5, 6, and then 6. So it's like the size plus 1 by 2 seconds, right? They only pick only one line, one substring which has one substring, let me tell you, one substring of all these hashes. They take that and cancel from the right and also from the left. So the size plus 1 by 2. Now one thing, imagine I have like this. I have the string like this. Star, 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 hash, and then star, star, hash for 4 times, and then a star, hash for 5 times. That's it. This is the given string for us. How can I calculate? Just imagine these as zeros. The asterisk is, however, not a line. So zeros, and then 1, 1, and then 0, 0, 1, 1, 1, 1, and then 0, 1, 1, 1, 1, 1. Imagine, I'll start with 0. So ones will not get updated. Ones is equal to 0 till now, and then 0, 0. Now I have a 1, so increment it by 1. I have another 1, increment it by 1. I'll get 2. Now I have a 0. What I'll do is, the size I got is 2. So 2 plus 1 by 2. What will be 2 plus 1 by 2? 3 by 2. 2 ones 2, right? So I am saying that for 3 as the size, 2 as the size, 2 as the size, I would get only 1 as the answer. That's it, right? So size plus 1 by 2 is the answer I am derived. 2 plus 1 by 2, 3 by 2 is still 1. So answer will be updated from 0 to 1. That's the maximum I can get. Now, as I have 0, I would update it to 0 again. Ones will be updated to 0 again. Now, again is 0, still 0, 1. So increment to 1. 1, increment to 2. 1, increment to 3. 1, increment to 4. Now, what is it saying? It is saying that I have a substring which is of all ones or hashes. Then I got as asterisk, so it is 0. But before that, let us see what I would get for 4 as the size. 4 as the size, I would get 2. Let us calculate. The size is 4. 4 plus 1 by 2. 5 by 2. 5 by 2. 2 2's is 4, right? So our answer will be updated to 2. Then one thing, as I got 0, then our ones will become 0 again. Then 1, so 1, and then 2 here, and then a 3 here, then a 4 here, and then a 5 here. Now 5 is the size. If you say I didn't get an asterisk, the liar end, I think I pronounced it correct, bro. So the size is 5, right? So 5 plus 1 by 2. That's what we did every time. 5 is the size. 5 is the size. 5 plus 1 by 2. 6 by 2 will give us 3. So we'll update the answer to 3. So how do I write the code? One thing, algorithm is simple. Let the ones be 0 and the answer be 0 for every character in S. If C is equal to, C is hash, then ones will be incremented, right? Now else I need to do two things. One, calc or update the answer. How do I update the answer? I will update the answer as answer is equal to max of answer comma ones plus 1 by 2, right? Now our answer, sorry, our ones will be made as 0 as we didn't have any ones, right? After this, there might be a case where we don't have any asterisk after all the hash, right? After the lines, right? The string might be ending with the lines itself. So, so at that time, I need to check if ones are present, ones are greater than 0. Then what I would do is I would update the answer. Answer is equal to again max of answer comma ones plus 1 by 2. So if this is the case, then we'll return the answer at that. So I thought of writing the algorithm, but I ended up writing the code. So that's the same code which I submitted. You can look at the code. I'm so sorry. Okay. Yes, this is the code which I have. So hash means nothing but once. So instead of having the maximum continuous ones, maximum subarray with ones, we are just doing it with hashes. And instead of calculating directly max of answer comma ones, we are just doing it ones plus 1 by 2. Number of ones plus 1 by 2. Why? Because as you already knew, they'll be cancelled off, right? They'll be cancelled off from right and from left. Iskandar and Yura, they both will be cancelling out those lines all once. So I hope it's clear for you. Please let me know if you are having any trouble solving the problem. Right. I think we are good to go for the second problem. And if you have any doubts for the first problem, please let me know. And I hope by giving these many contests and also doing live stream, I'm not only aiming for the subscriber count, but also the problem solving ability in Codeforces should also be increased, right? I could not solve problem C. Wait, let me go to the problem. I didn't even open the problem. Tilak, write your name. Stephen found a permutation P of length n. Of course, we decided to sort it to make the process more equal. Choose two positive integers x and y and define a rule for swapping elements. In one move, Stephen can choose two integers I and j and swap the elements pi and j if at least one of the following conditions hold. I and j absolute difference should be x or y. Stephen wants to know whether it is possible to solve the permutation in ascending order using any number of such options. Okay, that's a great question, I think. Okay, he also gave the numbers which we need to. I think we only need to choose that numbers, but x and y he already gave. The second line of each structure contains n integers p, and another p is a permutation. It is guaranteed that the sum of n over all test cases does not exceed 2 into 10 power 5. I think it can be solved with some sorting problem, right? It is some kind of sorting problem. I guess that's the third problem in today's Codeforces contest, right? 6, 2, 2 and 4. What they are saying instead, you can get these indices 2 and 4, right? 2 and 4. 2, here 2 and here 4, here 1 and then here 3. Okay, Tilak, you said your logic is not working from test 4. Can I know your logic? I'm thinking in a different way. I know graphs would not be a better idea. I'm not saying graphs, right? Recursion. So the problem goes like this. Aryan Mori, thanks bro, thanks for your motivation. Let me tell you. Imagine the first test case. Imagine the first test case. Let me write it. How I'm thinking. Why isn't it working? There might be an issue here. Okay. Sorry. Let me tell you. Aryan Mori. Thank you bro. Thanks for attending this live session and telling me that we can solve it. Let me tell you. We are given it 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. Now, the one which we need is 1, 2, 3, 4 and 5. If you see, we have x is equal to 2, y is equal to 3, right? So, can we think like this? Can we go from here to here? They are both the same things. So, we can only swap these two, or these two, or these two, or we can swap these two and these, right? That's what it means. Now, imagine what is the possible way. I'm thinking like if I select the first option, 5, 4, 3, 2, 1. Let me tell you. I have 5, 4, 3, 2, 1. Now, what are the things which I can swap? X is equal to 2, y is equal to 3, right? So 5 and 3 I can swap, 4 and 2 I can swap, 3 and 1 I can swap. Or 5 and 2 I can swap, 4 and 1 I can swap. I would choose 5 and 3. What would be the result? Then 5 and 3 is 4, 3, 5, 2, 1 would be the result. What if I choose 4 and 2? Right? 5, 2, 3, 4, 1. What if I choose 3 and 1? 5, 4, 1, 2, 3. Right? Now, I can also choose uh, I can also choose swapping 5 and 2. So 2, 4, 3, 5, 1. Or I can get 4 and 1 will be swapped. 4, 1, 3, 2, sorry, 5, 1, 3, 2, 4. Now, there are another things. Here, nothing is, sorted. I can swap these two, and then these two, or these two, right? I'm thinking like I can make it in 2 or 3 steps, but let me tell you, I might not. So 3 and 5 are swapped. 5, 4, 3, 5, 4, 3, 2, 1. Got it. That's the same thing, right? No. This, let me tell you, this is the same thing as I mentioned above, right? So as we applied the same swap, the first swap, so I cannot apply this first swap. I can apply instead, or not apply this. Instead, I would apply like this. These two, 3, 2, 5, 4, 1, and 3, 4, 1, 2, 5. So yes, I can apply. So I can also apply for this 2 and 3 would be 2, 4, 5, 3, 1, and also these two 4 and 1, 3, 1, 5, 2, 4, 5, 2, 4. But none of them are, sorted. But I cannot do this again and again. Let me tell you, for only 5, I have how many things? Like imagine I can have 5 different. For this 5, I have 5 or at least 4, something like that. But that's not the optimized case. So we need to have it in another way. We need to solve it in another way. So okay, the coding phase. Okay, so what if, just tell me, 214,365 and x is equal to 2, y is equal to 4. We need to either just prove one thing. Can this 2 will come to this position? That's the only thing I need to do. Let me tell you. I would go here 1, 2, 3, 4. I would go here. I would go here. Now this 2, it can go here or it can go here. It cannot go beyond. From this 6, can it go to 4? Yes. Can it go to here? Yes. But if you see, just just let me tell you, this 2 cannot come to this place. That's the place which needs to be there. 1, 2, 3, 4, 5, 6. But 2 can never be imagined in the place of this. Why? Why? Because all the gems will not lead at that point. What if x might be 3 or y is 4? I need to figure it out. 214365. Okay, 214365. Now think about this one. X is equal to 2, y is equal to 4. Right? Now think about this 1. It can go here, it can go here. From here, where it can go here. That's it. This can go again here. That's it. Nothing else. This one cannot go at this point. No matter how many transformations you do, right? So I need to find it out. I need to find it out in a way where there is no way we can find the correct place by just swapping. Let us take this 5432 and I think I have to do this. I'm saying sort the elements. If the original elements, if even one element in its original place can come to the sorted place, return false. I'm saying this. I need to prove this, right? If I'm saying that sort the elements, if even one element in its original place can't come to the sorted place by applying swaps, all swaps, 1, 2, 3, whatever x and y swaps, then return false. I need to prove this, and let me take this example: 5, 4, 3, 2, 1. 1, 2, 3, 4, 5. X is equal to 2, y is equal to 3. Now, let me prove this. From here, it can go here. So 1, it is sorted. 2, it can go 2 places here, so it is 3 already there. 4. 4 can go from here to here in just one step. Yes. 5, 2, and then 2. Yes. So, we are just checking for each and every element. So I think for every element there might be n number of swaps, right? 4, 2, 2, 1, 2, 3, 4. That's also easy. 4, 2, 2. Sorry, 1, 2, 3, 4 is already sorted. We don't need it. 1, 2, 3, 5, 4. X is equal to 2. Y is equal to 3. That's interesting. Let me do. So only the sorted one is 1, 2, 3, 4, 5. Now 4 needs to be coming here. So let me tell you, 1 and 1 is already sorted, 2 and 2 already sorted, 3 and 3 already sorted, 5. Let me tell you. So 5 won't go to 2, right? So it isn't possible. So it can go here, and then it can go here, right? So 5 is sorted, already got 5. Now I need to go from 4. Can go from here or here. I think yes. to here, and then to here. -3 plus 2, minus y plus x. So yes, so our logic is correct. Correct. If an element can't come, how can I let me tell you. How can I say where to stop it? Right? Let me tell you. If an element can't come to its sorted position, is your approach the similar way, Tilak? Let me know. Sorted position by applying plus x minus x plus y minus y. Nothing but swaps. Swaps. Then return false. Let me tell you where would I stop it. Let me tell you. Imagine, just imagine. I have the second example was 2, 1, 4, 3, 6, 5, where x is equal to 2, y is equal to 4. Let me tell you, this 2 couldn't come here, right? So I would apply, first I would apply here, then it can go here, or it can go here. Now it would go here and stop. Let us say 0 plus 2 minus 2 plus 4 minus 4. I solved C using BFS. Basically you get all the groups that are reachable with each other. Sort those group of indexes and then check if after overall sorting you get the right answer. Okay. You could go 4, 2, minus 2, minus 4. 0 plus 4 is 4 plus 2. Yes, I think that's the great BRIM SVP. That's the great approach to solve it, right? BFS approach. Let me see. -2. Stop it here. -4. Stop it. 0 minus 4 is -4. Right. So from +4, we can go to 4 plus 2 minus 2 again. 4 plus 2 would be 6. Minus 2 would be 2. Sorry, plus 2 would be 6. Plus 4 would be 8. Minus 2 would be 2. Minus 4 would be 0. Are we going with the same? Yes, as you said, if we have this BFS, we might have visited graph, right? Visited for every, okay. I think visited would be a grid, right? How many indices does a 0 visit? Did a 0 visit 0, 0 visit 1, 2, 3, 4, 5? If it has visited, then we don't go there. Yes, you are right. BRIM SVP. That's a great idea. So we would place, let me tell you, we would do a BFS for every index, but before that we would create a visited array, visited of n, comma, vector of bool of n, comma, false. Yes. vector of bool visited. So for every index, for int I is equal to 0, I is less than I plus plus, I would call for BFS for everything. But first thing, visited of, okay, nums of I, visited of I, nums, nums of I, of I, no I, nums of I, of I, instead of nums of I is nothing but, imagine I have an array like this, 2, 1, 3, 5, 4. So I am saying that 2, 0, 1, okay, 1, 2, 3, 4, 5. Did 2 visit 0, 1, 2, 3, 4? Did 2 visit 0? Yes, it has visited. And did it say the first listening 1 to n? So they said that 1 to n. Let's solve question number 4. Neuroflex. Let me complete with this one, bro. Neuroflex. Thanks for attending this live session. So yes, so 2 is present at 0. I'm just marking it as visited. So visited of will be true. Will be true. Then I would search for BFS. Would be a good idea, but let us see. Q of int dots in question number 4. Yes, bro, I didn't solve it, but let me tell you, let me explain you about the problem, right? Let me tell you, right? Q dot pushback, Q dot pushback is nums of I or I, right? So for int I need some directions, right? As in BFS, so vector of int directions is equal to plus x minus x and plus y and minus y, right? So for int dir in dirs, let me say that as new x or new index is equal to the current index which I have at I plus dir. So if it comes under the constants, if new index is greater than or equal to 0 and new index is less than n and it is not visited, right? Visited of nums of I of new index is not visited, then what I would do is visited of nums of I and new index, nums of I and new index would be made as true. Then in the queue I have pushed back, but I need to write the while loop. Yes, I'm missing some things, right? While queue is not empty, so queue dot push back, just push new index. right? So new index right, it should be index here instead of I, index plus vir, index plus vir here. Here it should be while loop. While queue is not empty. Is not while queue is not empty. In index is equal to q dot front q dot pop, right? That's the while loop, right? I think I'm clear with this. One thing I would say, just give me a minute. Right, I think this code works. Why? Because so we are making nullify of I is equal to, sorry, is equal to true. I think it's clear. So I think we need to execute it. That's the next part. Right? Let me take it. I have the option question. So this segmentary, yes, bro. Krush, right? Your name. So we'll solve it. We'll look at it. And I think most of the people have already solved the second problem, first and second problem. That's the thing. The third problem might be the one which should be, you know, not hardest. I won't say that it's the hardest. But say no, just tricky, right? We can. There might be some errors. Let me know if, excuse me, if I have any errors in this. If it's not listed, so fine, it's not listed. Yes. So I think we are good to go. First thing, we'll be having T and then n and then x comma y, and an array of will be having nums, right? Nums, okay. Int n, c in n. Now int x comma y, c in x and then y. Can I know what would be the rating of that problem? Don't exactly know, bro. How? I cannot even say that. I'm new to this code for, so I'm not solving from here. So I'm not good enough, that good enough to tell you this. Might be like 1100. Okay, is it? I don't know. I'm thinking like 900 something somewhere. It's okay. X and y, and we'll be initializing a vector of int of nums of n, right? So for int I is equal to 0, I is less than n, I plus plus c in array, sorry, nums of I. So we got our array and x and y, right? New fix, yes. So let me know your real name if it's okay. Vector of int, yes. And let me know, is it a correct way that we are having x comma minus x comma y comma minus y? I think so. Well, let us see. Vector of vector bool visitor of n comma vector of bool of n comma false. Right, for int I is equal to 0, I is less than n, I plus plus. What we would do is visitor of nums of I is equal to 2, right? Then we'll initialize q of int q, then q dot push I. Now, while q is not empty, while q is not empty, let's take the first index. Int index is equal to. Why it's so hard? The biggest challenge is figuring out is a graph. Does someone know the possible rating for p comma c? Let me know, bro. Is it that important for knowing the? I don't know. I'm new to this code forces. P is around 900. Yes, I'm also thinking it 900. I have solved one or two, like 9 problems in total in code forces itself. If new index is greater than or equal to 0 and new index is less than n, and also is not visited of so I and I, it's not, sorry, not I, num index, right? Then not here, it's not here. Then visitor of nums of I, new index, will be made as q dot push new index, right? That's it, I think, from my side. While I have this while loop, but after this for loop, let me tell you, I have sorted indices, right? So let me store in an unordered map of int comma int sorted index, right? So what I would do, first I would sort vector of int, uh, sorted nums would be equal to the nums which I have. Now I would sorted nums dot begin, and which programming language are you using? I want to know that should I just continue with this C++ or should I convert or shift to Python or Java. I'm doing this in C++, so let me know. So for int I is 0 I is less than and I plus plus, what I would do, sorted nums of I is I. So the elements sorted index will be I, right? The element sorted index will be I. So what our aim is, sorted index okay, let us not overcomplicate it. I have the sorted index where it fits. Okay, I already have the sorted nums, right? I have this sorted nums. Int element is equal to sorted nums of I. Int sorted index. Let me just comment it for some time. Sorted index is equal to I. So this element should be at the index sorted index. So what I would do, will that be visited or not? Visited of the element and that sorted index, is it true or false? If it is true, if it is true, then what I would do is I would just skip it. But if it is false, what I would do is see out no. That's what I was asked with. Yes or no. No, right? So no and L. Just if this is the case, then just do one thing. Then just do one thing. After this, just break it or just have a flag. Flag is equal to false, and then break. If flag, what I would do, C out yes and L else, C out no, no and L. But before that, let us say bool flag is equal to true. Let me take this above as I have nums here itself. So what I would say, if sorted nums is equal to num, just C out yes and do one thing. Just continue. I think I need to have this input. I must change the input first. Flag. This will be for Y. Okay. Let me take the input and let us see whether this would work or not. Let me run. Num index, new index. Okay. The data went wrong. The line number is 35. 35 new index. Okay, new index. Everywhere it will be new index. It is already new index, but only one time I was. What happened? there, there is an error. Let us see. Right. I'm thinking, right, let me tell you, like, imagine I have 5 elements, 1, 2, 3, 4, 5. Now I'm creating for how many? The visited. How many I'm creating for? 0, 1, 2, 3, 4. When I say 5, where will it go? It won't be going anywhere. So what I should do is n plus 1 here and n plus 1. Sorry, I forgot to have the input. Sorry for that. It might be taking much time to my uh, successfully executed. Yes, no, yes, yes, yes. Okay, we are good to go. But I don't say this might be the most optimized. Excuse me. Right. Let me tell you why. Why? Because t is already 1e4 and n into n. What would be n into n? 2 into 1e5, 1e5 into 1e4 into 2. That might be the case. And I think there are no additions or multiplications we are doing, but I think long would be better, but I don't see any case that I can have this long. Let us submit the code. And meanwhile, if you have any doubts, let me know. Let us see. Yes. As expected, memory limit exceeded contest 3. Let us do one thing. Instead of having vector of vector bool visited of n plus 1 and all, let us create pair. If 1 can go to index like 3, I would say in unordered map can visit in a pair 1, 3 can. Is it true or false? If it is true, I can definitely say. What are the other data structures? I might have 1, I can visit 3 and 4 and 6, something like this. From 2 I can visit 1, 8, 4, and then 8, something like this in an unordered map, but I cannot do that. So can visit might be the better choice. Can visit in a pair can be true or false, but if I search for a pair, it might not be there. Right? It might not be there. That's what I'm thinking. What if I create a string? Right? First, let me try with a pair. And then I might go with the string. What I'm thinking is unordered map of pair int comma int comma bool. Let me name it as can visit. Let me write the code. Let me refine the code. Instead of having this visited, I think I cannot do that. Can visit. So the unordered map will be unordered map of pair of int comma bool can uh, can visit. Let us say where do I have this can visit of nums of I comma new index is false, right? This might not work. I am thinking like why, because I am searching for this pair exact. This pair, let me show, can visit. Okay, here again I'm thinking this way, can visit. I have to put it in this way. The pair should be there. I'm no need of this brackets. So let us have this input. And I'm thinking that this pair would now yes, compilation error. So key hash key and key is pair and as expected. Uh, what if I had a set of int? Int. So instead of having this like this, we'll be having can visit of uh, nums of I can visit I, right? So q dot push I while he is not a main. The index is equal to q dot front, q dot pop in direction new index is this, new index can visit. Int find is equal to, let me take the set of int current set is equal to can visit of nums of I. That's the set. Can I take this as a flag in set? set is equal to current set dot find new index is not is equal to current set dot end. If this is the case, then what I would do is bool inset would be is false. If this is the case, inset will be true, and if it is not there in set, if inset is equal to false, right, then only go with insert can visit of nums of I dot new index can visit. Let us take the set. Just take a set like current set dot find as index is not. That means I already found it. If I didn't found current set dot end set of int current set is equal to can visit of year, right? If I didn't find it, then break it. Let me just run it first. Where is this index? 49. Where is 49? Insert, so insert new index. Yes, let me have current set of index passed by reference here, and let me say the same thing, passed by reference everywhere, right? Okay, so that's it. Let me again go again. I think this is the first time I am submitting the first. Choose problem C. Problem number C. Submit it. Okay, we have got a time limit exceeded. When are we exceeding the time limit? We are just doing the BFS. Might be okay. Let us do one thing. String comma int, or can we have set and set of int. Can we have string comma bool, right? And let me code this everything out. First, let me remove this. Is there anything else? Let us do one thing. I'm just checking any, will there be any error if I have string? Just checking. Yes, successfully executed. But how did I get this? Yes. Okay. Yes. Understand. Let us do one thing. Let us do one thing. Let us ask cout of if can visit of, let us take a string, something like this. If it is true, cout it is okay. It is not okay because it is giving us true, right? Else cout okay, right? Let me run. If you are new to our channel, meanwhile, you can just execute. Okay, it's giving me okay. Let me show you my channel. We will be solving DSA stuff. Okay, as we have understood, we need to just execute it instead of having like this. Let us take a string temp is equal to string nums of I plus a hash plus string I, right? That's it. So can visit of temp will be equal to true. Now again, do we have a can visit? Yes. We don't need is set or not. We just need here is equal to false. Can visit of, what is the I, new index. So nums of I. Let us take a string temp or current string is equal to, let us say, the nums of I and the new index. Sorry, this was the new index. Is it nums of I? Yes, nums of I and new index. String current string is equal to nums of I and new string new index, right? So one thing, if it is false, current string is false, can visit dot insert instead will be having index. So instead we'll be having current string is equal to true. That's it. And here let us have string temp is equal to string element plus a hash plus s index to string s index, right? So if it is false, or can visit of temp is equal to false. Let me run the string. How can I change it to so only one thing SRI, okay. Successfully, we don't need this, just need yes, no, yes, yes. Let me copy this and then submit the code here. Okay, no. Time limit exceeded again on test 3. I think converting, where did I just go in much? I just went. Is it converting to string or is it the BFS? But the approach, I think the approach is quite straightforward. I think it's not a great approach. I think. Let me know if. Yeah, I was about to show you my subscribers. Only 29 subscribers now. Get 1100 subscribers, right? It's okay. I wasn't able to solve the time exceeded thing is something to check, and I'll check this thing. Might make a video on this. Let us see. In this code fixes the problem with this code fixes you can solve barely 3 or 4 problems, right? So it's already 11:25, 11:21. You're having 4 problems. So that's it for today. Let me go to the live. So if you have any doubts, please let me know in the comment section. And that's it. Thanks for watching this live stream. I will be meeting again in this Saturday. There will be bi-weekly contest this Saturday in LeetCode, so be there. Thank you. Thank you very much.